Alright, I don't know how the sound quality is going to work on this, but I'm Benjamin Watson, and this is going to be General Chemistry 1411 Labs 1 and 2. So the first thing we need to do in this experiment is gather our metric ruler, CD, DVD, key, spoon, and fork, and look at the calibration marks on said ruler to determine the degree of uncertainty and the number of significant figures we can record. So we're doing things in the metric system, and I don't know how well that's going to show up. But the ruler is calibrated in tenths of centimeters, which is also millimeters, which means we can record to an uncertainty of hundredths of centimeters, or tenths of millimeters. That being said, the first thing we're going to do is measure the length of a few objects here. So I'm going to get on that, I'm going to record the results, and I'll be right back. Alright, the next step in our fine adventure, after having recorded the lengths of various objects, is to record the temperatures of various things. So here we have 75 milliliters approximately of hot tap water, and we have a thermometer calibrated in degrees Celsius, centigrade. Geez, maybe there's a difference. Anyway, since it's calibrated to each degree, we can estimate using our uncertain figure to tenths of degrees, and that's what we'll be recording. Right. So we're looking at about 46.7 degrees here. And since we're going to be playing with fire, it's important to remember your safety equipment. Here comes the fire. And time to boil some water. I have temperature resistant hands, but I also have temperature resistant gloves. We'll be right back. Alright, I've just been informed that in order to use centigrade you have to be in Europe or of European descent. I'm going to have to use Celsius. And we're just about to have boiling water here to measure the temperature of immediately. It wants a full boil. We are almost there. It's just like dead air on the radio. It's just no good. We're going to take some measurements of boiling water and come back. Alright, now I have boiling water. When I took the temperature, it was 95.6 degrees, and now we're letting it boil for 5 minutes before taking the temperature again. So, somewhere is a running stopwatch here. Alright, our stopwatch has reported that 5 minutes have passed, so we have our handy-dandy heat-resistant gloves for safety. And we're taking the temperature of the boiling water after 5 minutes of boiling. I call that 96.1. Our 96.1 here. Turn this baby off. Alright, remember to take great care with the following procedure. Heat resistant gloves, very hot beaker of water, very hot piece of metal. Let's see, we'll just put you here, and we will slide you that way. It looks hazardous, doesn't it? Just cap that. And it's time to get some cold water to measure. Since I did that off screen, you'll have to wonder what's in my red solo cup. Looks about 26.6 degrees in there. We're going to call that cold tap water. And now we will add some ice, wait 1 minute, and take the temperature again. We're going to take the temperature at 1 minute and at 5 minutes. We'll be back. Alright, we're done talking about temperature for now. Now we're going to do mass. So we're going to weigh some objects on this scale, which is calibrated to the nearest tenth of a gram. Don't think we're going to be doing any estimations with the scale, just recording what it says. Right, so we have objects such as this pen, this key, these coins, and we're going to start weighing them. Alright, now we're going to be looking at liquid measurements, and one of the things we'll be using to do this is our little plastic cylinder here that's graduated in tenths of a milliliter, which means our degree of uncertainty will allow us to record data to hundredths of a milliliter. So, I'm going to start by tearing the scale, and we record the mass of the empty cylinder first, 16.4 grams. And now we're going to fill this with 5 milliliters of distilled water, which here we have some distilled water. You know, it looks like this is actually graduated in 1/2 milliliters, so retract some of that previous stuff. And one of the problems I ran into in setting up this experiment is after going to 6 different stores, I could only find a 91% solution of isopropyl alcohol. So that's liable to throw our results off a bit. We'll talk about that later. Alright, in just a minute we're going to start measuring volume using both a three-dimensional ruler method, for lack of better terms, length, width, height, that sort of thing. But before we get to that, the way we're going to handle this 91% problem is I've been given an accepted value for, the density of water and an accepted value for the density of isopropyl alcohol. So I'm just going to mathematically generate an accepted value for 91% isopropyl alcohol, assuming that water is the other ingredient, so that I can get my percent error correct. Right, so now we get to measuring objects. Just a side note, since we're calculating density of objects in addition to volume, we're also going to need mass. So, here we go. Alright, now we're going to calculate density using the displacement method. And of course, to do this, you need mass. The mass of the 2 objects we're going to be measuring. The first one's a magnet, 4.5 grams. Second one's a metal bolt. Weighs in at 7.9 grams. Alright, so I've measured out 8.0 milliliters of water because we are calibrated in. It's actually half milliliters, but we're going to say we can calculate to the nearest tenth based on that. Right, so it's 8.0 milliliters of water. And the first thing we'll do is add a magnet to some water. Looks like about 9.0 there. For the total displacement, and then we're going to do the same thing with this bolt. I've measured out 8.0 milliliters right there. We're going to get rid of this for a minute. I'm going to call that 8.1. We add a bolt. We're going to do that again.